So if we look at figure 12.6, so this is an approximate diagram of what is there in the book. Now it says we need to find the ratio of highest to lowest intensity. Now this line here is the lowest detectable intensity, or we call it threshold of hearing. So let's put a star mark here and connect that to this guy. So that's threshold of hearing. And this line right here is the threshold of pain. So let's put a green star over here, and that's our threshold of pain. So that's the range that we have on our hearing. Now at 100 hertz, so let's say this is our 100, and at 100 hertz we need to see what intensity we get for threshold of hearing and for threshold of pain. So that will be our highest intensity and that will be our lowest intensity. And this is an approximate number because this we are approximating this point. And so the lowest or the threshold of hearing is 5 times 10 to the power minus 9 watt per meter squared, and threshold of pain is about 5 watt per meter squared. So if we take the ratio of highest to lowest, we get something like this. So we'll have 5 over 10 to the power 5 times 10 to the power minus 9 watt per meter squared, watt per meter squared, and they get cancelled, and the ratio is going to be 10 to the power 9. Right. And we can do the same thing for 5000 hertz. So for 5000 hertz, the threshold of hearing, so for 5000 hertz, the threshold of hearing will be, if you again looking at the graph, it's gonna be 10 to the power minus 13 watt per meter squared, and threshold of pain, that's gonna be close to 10 to the power minus 1 watt per meter squared. Now again we do the same thing, we take the highest to lowest intensity, so highest over lowest, and that gives us 10 to the power minus 1 watt per meter squared over 10 to the power minus 13, 10 to the power minus 13 watt per meter squared, and that comes out to be 10 to the power 12. So that is at 5000 hertz, and this guy right here is at 100 hertz.